Hello, my name is Phil. I work for MediaTek Labs and I'm delighted to be here and to see so many people. I have to say it's my first trip to Russia and I will go back on Tuesday, but it's been amazing. It's been an amazing 2 weeks and it's really nice to be in Russia. Right, to the masterclass of this afternoon. What are we going to talk today? First I will give a brief introduction of MediaTek. You might have heard about MediaTek, maybe not, but I'll just talk a little bit about it. And then a bit more detail about MediaTek Labs. That's the team that is here today at the Geek Picnic. It's a developer program, so we'll talk about this. Then about the LinkIt ONE, the hardware development kit you already saw here. Then about the software development kit, so that you can program these hardware development kits. Then I talk about the MediaTek Cloud Sandbox, which is a free cloud solution for developers to use to store data in the cloud. After that, I will talk you through a short demo of how to get this board connected to a temperature and humidity sensor and upload it to the cloud. And in the end, I will talk quickly about two other hardware development kits we have on offer. So first, about MediaTek. MediaTek is a global company. We have about 12,000 people worldwide, and we have offices in 12 countries. Myself and my colleague, we are based in the UK in Cambridge, but as I said, we're in the States, we are everywhere. What do? We do system on chips. This means the brains of many devices. Tablets, smartphones, digital TV, Blu-ray player, even game consoles. So there are chips from us in the Xbox One and also in TVs. So it's very likely that you are in touch with our chips on a daily basis. Because we have global leading positions. So in smartphones, we overtook Apple last year. We're now number 2 in the world in terms of smartphone shipments. Tablets as well, number 2. Digital TV, number 1. So we're a very, very big player. That results in some really cool products that are powered by MediaTek chips. To begin with is a Sony Android TV. This was launched beginning of this year at the CES in Las Vegas. Then the Amazon Kindle Fire, you probably have heard of that as well. It's also powered by a MediaTek chip. And there are many, many smartphones. One of them is the HTC M9 Plus or the Google Android One. But we also have like Lenovo, HTCs, etc. So that's enough about MediaTek. Let's talk about MediaTek Labs. MediaTek Labs is a developer program. So we take the system on chips from MediaTek and create hardware development kits, create software development kits, and offer services to developers. We want to we want to inspire people to realize their potential, realize their ideas. So you should just have an idea and we then provide the rest. How do we do that? We have our portal, labs.mediatek.com. On there you'll find technical documentations of our chips, of our hardware development kits. You find SDKs you can download for free. You could also ask questions. We have a very lively forum, so thousands of developers around the world are connected to our platform and they're asking questions, talking to each other, talking about projects they're having. And furthermore, we have business support because we realize that a lot of you have great ideas and put them into reality, but what's next? So you have a prototype and you want to start putting it into production, but you have no idea how. That's where MediaTek Labs Partner Connect program kicks in. This is a new initiative from us to help developers like you put your prototype into manufacturing. It could start from like 50 or 100 devices up to 1 million, 2 million, however many we want to produce. MediaTek as a large company, we have lots of connections in manufacturing, in components, in sensors, whatever you need. We are very happy to extend these connections to you, the developer, and give advice on who to use and why to use them. So don't hesitate to contact us, our team, if you're interested in this Partner Connect program. This is one of our success stories. So Omate, a Chinese-based smartwatch company, they created the Omate watch, which is a smartwatch based on the chip we have on our hardware development kit. And as Laurent states here, it was crucial so they could just focus on the design of the device and could just rely on MediaTek for providing the technology, the support for their needs to develop this watch. So let's talk about the LinkIt ONE, the hardware development kit. What did we do? We took our Aster system on a chip, which is currently the smallest system on a chip available for wearable and IoT devices. It has a very small footprint and is very power efficient. So we took that, and also we took our GLONASS and GPS chip, the MT3332, and the Bluetooth Wi-Fi chip, and created the LinkIt ONE board. A very compact board which offers a lot of functionality. But once we created that board, we realized it has to be easy to use. It has to be very simple to set up and also then to program to create your projects. So we created our own operating system for it, a real-time operating system with also a plugin for Arduino. So if you already use Arduino, it's very easy to port your projects onto this new platform. So this is the board from the front. We have digital input-output ports on the top here, 16 in total, and at the bottom we have analog ones. This is the same pin layout than an Arduino Uno, so you can use shields that you maybe previously used with other boards. On the side we have the SPI port, again at the same location than an Arduino board. We also have Groove connectors. This is a system by Seed Studios, which makes it very easy to connect additional sensors. As you can see here, it's the temperature, humidity, and all you need to do is to plug it straight in and it will work. We have different jacks on the side, a headphone jack for your headset, so you can play back music, you can record music. You can also do phone calls with this board. We have a USB jack to upload your sketch, and then a battery jack to connect the battery, which is included in the whole hardware development kit. We have a reset button, which comes in handy when you're developing. And we have some switches to configure the board for different settings. This is the rear view of the board. So we have the GPS antenna on the top. This antenna is not just for GPS, it's also for GLONASS. So we support both global navigation satellite system. We also support Wi-Fi and Bluetooth and GSM. There is a SIM card slot and an SD card slot on the board. And these are now our chips. So the top one in the middle, you can see this is the GNSS, the GPS GLONASS chip. In the middle is the Wi-Fi Bluetooth one, and at the end is the main processor, which handles the GSM part and also the whole board. It's the MT2502, or also known as Aster chip. Some specification. So the chip itself is a ARM7 processor with 260 megahertz. It has 4 megabyte of RAM and 16 megabyte of onboard flash memory. We have 16 digital input-output pins for 3 analog ones, and we also support pulse width modulation. We have external interrupts on 2 pins. We support I2C, SPI, UART. We also support GSM, GPRS, so data connection via 2G, and Bluetooth both like the 4.0, the low energy one, but also the normal Bluetooth. We have Wi-Fi support on the board and GPS. And we support GLONASS and GPS, and also the Chinese navigation system Beidou. This is one of the documents you can download from our website. It's like a pin-in-out diagram. So we have lots of technical documents, also like reference designs you can download for free on our portal. Now let's talk about the software development kit. We put a lot of functionality onto the board, but we wanted to make it as easy as possible for people to take advantage of all this functionality. Hence, we created an operating system and also a plugin for Arduino. So how do you set it up? It's very simple. You have to install Arduino if you don't already have it. You go to our website, you register if you're not already registered, and you download our SDK completely free. This is a Windows installer. We also support Mac, so you download it and you install it. The only thing you have to configure is the location where you installed Arduino. That's it. Everything else is taken care of. Once you did that, you can start up Arduino as usual, and you will see a new entry in the boards. You will see the LinkIt ONE board. You can select the correct COM port, and you just press upload and it will run. It will blink or whatever you want it to do. So as you see, like in 5 minutes you are up and running. The features of the SDK. We support all the core features of Arduino, as you can see on the left, but we added loads more. We started with GSM, and this allows you to send and receive text messages, and also to create and receive phone calls. GPRS, which supports TCP and UDP sockets, which means you can connect the board directly to a web server, to a web service, or to whatever you want to connect it to. Same goes for Wi-Fi. These are all included. Bluetooth, we support serial port profile and GATT. GPS is the NMEA format. These are comma delimited strings which have lots of information. You can get the longitude, latitude, the altitude, the speed over ground, lots of informations, they're all in there. Audio, we support different playbacks, and for the SD card we support FAT32 format. So let's talk about some examples. And as I said, it's very easy to use our board, so I wanted to prove it to you. So how easy is it to send a text message? I think it's very easy. What you have to do is you check if the SMS module is ready. You do that by calling lsms.ready. This gives you back true or false. This checks if you have network coverage, so if the board is connected to the GSM network, and if everything is ready to send a text message. Next thing you have to do is to begin your text message. You do that by call begin SMS, and you set the mobile number you want to send the text message to. You set the text of the message by lsms.print, and you can set as many characters as you want. It's not limited to 160. If you go over 160, it will automatically handle that and just send as long text messages as you want. And in the end, you finish it off by end SMS. This again will give back true or false, which indicates that the text message was sent successfully or failed, and you can try again. So as you can see, in about 4 lines of code, you manage to send a text message. You obviously can make more sophisticated functionalities than just of sending one. You can also listen to incoming messages, which will be lsms.available. So you can just check if anything comes in, and can control a home automation system via GSM, for example. GPS or GLONASS. We are very conscious of the power consumption, so by default we have the GNS module switched off. So what you have to do, you have to call LGPS and power it on. At that stage, it will try to get a fix on the location. Next thing is to get the data. So you pass in a structure into lgps.getData. In this structure, you will find all these different NMEA strings I was talking about earlier. So the only thing you have to do is to pass these strings. But these strings are just comma delimited one. So you have like different informations separated by commas. You can just read them out and do whatever you want. One nice thing to know as well is that GPS or GLONASS, they obviously have very accurate date and timestamps on it. So if your project needs a very exact time, you can use this feature to set your internal clock. Audio. Again, very easy to use. You start the module up and you play the file by calling laudio play file. You have to select which storage you're using, the flash storage or the SD card, but that's it. You can set the volume, so if you want it louder or quieter, and yeah, then you wait till the file is played and you can stop the playback. Let's talk about the MediaTek Cloud Sandbox. This is a very new feature we released about 2 months ago, and it is for developers for free to use. There's unlimited storage, and so it's just for like prototyping basically. There are RESTful APIs you can use to send and retrieve data, not just from the LinkIt ONE board, but also from a PC or from other web services, whatever. You can visualize data, and with it I will show you some examples. We have maps, we have graphs, we have controllers where you can switch stuff on or off, and as I said, you can control things. So you can control servos, you can control lamps through it. You can do it through the web portal, but you can also do it through an Android app we provide for free. And you can get notifications if certain values go above a certain range. So you set, if the temperature in this tent goes over 50 degrees, then please send me an email. Here are the different data types you can use for visualization. At the top we have a controller, so just a switch on or off. Then we have a simple type as well to signalize if something is on or off. And then we also have hybrid ones which show the temperature, and you can also select what temperature you want to have. These are some more examples. We have on the top left we have a controller, so you can switch a smart lamp to a different color, a map to indicate where your car is currently or your bicycle, and then at the bottom we have a graph to show the temperature over time. So let's come to the demonstration. So what are we going to do? We take this LinkIt ONE board, and as I said before, we have these growth connectors on the board which make it very easy to connect sensors. So here's an off-the-shelf temperature and humidity sensor, and all I have to do is to plug it into this growth connector, and that's it. I attached beforehand like the antennas for GSM and also inserted a SIM card, but we come to that later. But that's all the hardware is set up. So what do we do in our Arduino program? We have to include the driver for the sensor. So the sensors, they will come with their own files. So this is the dht.h. We include that in our sketch, and we have to define on which pin it is connected. So in this case it's pin 0, and what type of sensor it is. In the setup function, the only thing we have to do to read out the sensor is to call dht.begin, which initializes the sensor and makes it ready for readouts. The other thing on top you see there is just to print out onto the console so we can see what is actually happening. In the main loop, which is executed continuously, We then have two variables, float T and float H, one for temperature and the other for humidity. And then we call again our DHT, which is our sensor, and we ask it to read the humidity and temperature. And if that is successful, we print it out to the console and we wait for 2 seconds. So this now will, every 2 seconds, will try to read out the latest temperature and humidity measurement and print it out on the console. So this is a local program. So the board knows now what temperature it is in here, and I can see it on my computer. But this is only useful if I'm sitting in front of the computer. What if I want to know when I'm back in the UK what temperature and humidity it is here in this tent? I need to connect it to the cloud. So let's do that next. And you can use our cloud sandbox to do so. You can set up a free account, and we have a very easy to use portal where you can set up different data channels. So you create a new device and you say this device has a temperature and a humidity readout. This is the portal, as you can see here, and I set up these two data channels. But what next? We have to get the data from the board into the cloud. And we do that, we have two options to do that. One is Wi-Fi. We could connect to Wi-Fi, but because we're here out and about in this lovely park, we can't use it, so we use GPRS through the mobile network. How do we do that? We have a library to use GPRS. So we include that again into our file. Include LGPRS is the library that handles all the GPRS connectivity. And then we have a LGPRS client. This is to connect to a web server. And the others are just to make it work. So the HTTP client is specifically for connecting to the MediaTek Cloud Sandbox. In the setup function, you see it is very easy to connect to the GPRS network. It's the same story with the SMS. You just call LGPRS attach GPRS. Because different mobile operators have different settings for it, so a username, password, name, you are able to set these when you call attach GPRS. So these are the settings for Megaphone, the Russian operator. We check again if it's available, if it was successful, and if it was, we continue, and if it wasn't, we try again until we have an established connection to the GPRS network. But what next? Normally, when you use a cloud solution, it can be quite complicated to find the right authorization key or like headers for the HTTP request or the device ID. It can be a bit of a nightmare. Again, we wanted to make it very easy. So what you can do is you can go to the MediaTek Cloud Sandbox, you go to your device, and you click on API hint. And this will bring up a window like that, which presents to you code in different languages. So this is in Arduino, but we also have it for Telnet, jQuery, etc. And this code is exactly what you need for making it work. So you can just copy this, paste it into your Arduino sketch, and it will work. And it will upload the data directly to the device you created on the Cloud Sandbox. So you see, again, we took a lot of pain away from the developers to make you use it, and you can use it very easily. So this is the finished upload function. At the top, we wait until the client is successfully connected to the URL of the API. And then we basically create an HTTP post request. But this is all copied code, so very easy. So you see we have the data string where we use temp, which stands for temperature, and then we turn the float value into a string and upload it. And here you see as well the device key and the authorization is all taken care of, so you don't have to worry about that. So this would then read the data from the sensor, connect to the internet through GPRS with the SIM card built into the board itself, and every 2 seconds we'll take a readout of the sensor and upload it to our cloud, and then you will see a preview of the temperature over time. We have a demo like that running on our booth, so if you're interested to see that, you can come over to our stand and we'll show that, and I'm happy to show some code as well and how easy it is to use. We have some other hardware development kits, not just the LinkIt ONE, which I want to quickly mention. This is the LinkIt Connect 7681. This is a much simpler board. It has Wi-Fi connectivity and 5 GPIOs. So it is for maybe making a fridge smart, or a light bulb, or a plug, a light. So it's very simple. This retails for roughly $20. The LinkIt ONE, we just reduced the price to $59. And then we have the LinkIt Assist, which will be available in 2 days from now. 3 days, on the 24th of June. So it's brand new, and it has exactly the same functionality than the LinkIt ONE. So a lot of functionality, but it is half the size because it's based on modules, and it also has a capacitive touchscreen you can use to program and to display things. So this is ideal for creating a wearable or an IoT device. Please come to the booth. We have lots of time to answer questions. We have exciting gadgets from Russian developers, and we are here to help to answer all your questions. And thanks for your time.